Hello?
Hey, what's up, guys?
Hey, it's up.
Now better.
Back to normal?
Maybe I think by tomorrow I should be. Yeah. What's up, Jason?
Not much, not much.
Here. All right. This next course is going to be solving systems of linear equations and then graphing. So I something to do with the graphing, right?
It's solving systems of linear equations by graphing. Is that what it says?
It doesn't say by graphing, but there's equations and then it has the little dots and then graphing. So I would assume, yeah, by graphing.
Because there's a bunch of different ways to solve linear equations, but by graphing, all that means is where they intersect the x and the y for the point is the answer. So like you can figure out the x
okay.
and the y. If it's by graphing only, if it gets to the other ones, then I can show you how to do it. But by graphing, it shouldn't be that bad.
That's what I figured. I thought it kind of looked the same from this video I watched. But we can look. You want to look at it, and then we'll see what
yeah.
they do.
Because we did some of that stuff already, like where like find the point that satisfies both equations. That's
like the input and output.
Yeah, that's the same idea. Like we'll be doing the same stuff there, where you just go figure out the x and then you figure out the y.
Let's see what they got. But, they always got those weird questions. So
yeah. Okay. Oh. So.
See, it doesn't say by graphing, but it just
just the colon. But they're talking about this same idea. So. The thing where it says Henry wrote his equation. They discovered that his equation had all the same solutions as Fiona's equation. That means that the two lines are the same line, actually. Like one line lies right on top of the other line.
Okay, so the other one's on there, but you just can't see it.
Yeah. And one way you can play around with it is like Fiona's line, that's the blue line there. Henry's line is like directly right on top of it. If you plugged in, you see that point in the center. The what is that? 0, comma -5.
Yeah.
If you plug that into Fiona's equation, you would plug in the 0, and then you get 2/5 times 0, which is 0, and then 0 minus 5 is -5. So -5 equals -5. That's what you wanted. You plug in the x, and you should get out the y. You could do the same thing in like all the other ones. You just plug in both 0 for the x and 5 for the y. But that still might be hard because you have to deal with that fraction.
I could turn it into a decimal.
Oh, yeah. Turn it into a decimal and then multiply it. So like the 0, comma 5 should work on Henry's, whichever Henry's equation is. We don't know which one Henry's is. The 0, comma 5 should work on Henry's, where you change the x to a 0, and then you change the y to a -5.
Yeah.
And then it should equal whatever. When you multiply it and then do the subtraction, it should equal 25/4 if we're testing out that first one.
So if I were to do like the first one, right, I would do it's not like fucking 0 minus 5/4 or
it'll be 0 minus 5/4 times -5.
Okay.
And then so like you can write that part down. And so then there are no more variables. Now you just have to do the order of operations, which means the multiplication first. So you have to do the 5/4 times the -5. And so let me do 5/4 in the calculator. 5 divided by 4.
I don't know if I did it right, but I got -1.25 when I did the 0, which that should have been
Yeah.
good. And then I times it by the -5 and got 6.25.
Positive 6.25, right?
Yeah.
Yep. So 6.2.
That's the wrong one, right?
Times 5. Well, what is 25 divided by 4?
6.25.
So that one works.
Ah.
But I just want to make sure the other ones don't work too, because it says all of the solutions have to fit. So like you could the 0, -5, that should work, and then also that other dot -5, -7. That should also work.
Oh, on the left side.
Yeah, that other dot. So if you do the -5 for the x and
okay.
-5/4 times -7. So I'm gonna try that.
That one I got 31.25.
Yeah, I didn't get it. There's a better way to do this, I feel like, but I'm not seeing it right now. It's over 5. If we did the -5, so -5 and then -5 times -7 divided by 4. And then, yeah, so now the first answer isn't work because all of the solutions have to work.
Oh, okay.
So yeah, let's just try both of them on the second one. And then we'll pause it and then I'll talk about it afterwards. I just don't want to waste too much time. But 0, -5, we'll try it on the second one. Well, the 0, -5 doesn't work on the second one. So that's not it. I think it's probably the last one. I'm going to try on the last one.
The 0, works for the last one.
Yeah, 0, -5 works. And then just to make sure, let's do the -5, -7. So let's see. Yeah, it works.
That's the one. Yeah. You want me to pause it? Or?
Yeah. You can save and exit. I'm gonna.
Okay.
say some stuff. So for this one, like the key here was that they said Henry wrote his equation. They discovered that his equation had all the same solutions. So any number or any point on this line works in Fiona's equation. So you plug in like the 0, which is the x, you plug in that there, and then you plug in the -5 for the y. It works out. We talked about that. All of them should work out in Henry's equation. We did one of them, and one of them worked out. All right, we plugged in 0, -5, and that worked. So that means for this equation, whichever line that it looked like, it crossed this point. However, when we tried it with this point, it didn't work. Do you remember that? Yeah?
Yeah.
So that means that this equation does not look like this. Otherwise, this point would have worked. The line that corresponds to that equation would be something like this, where one of them works in here, but the other one doesn't because it should have been like a different point up there. So it crosses at one point, but not every single point on the line. That's the big idea for why that single point, the 0, -5, it worked on that equation because that line also would have gone through that point, but not all of the rest of the points. This was the case where, like, if you're solving something and there's exactly one solution, that means the two lines cross once. If you have something where there are two lines, say that's like this and like this, where they're parallel, that means they never cross. That means they don't have, there's no solution. They never cross, so there's no solution. That's when the slopes are exactly the same. So the slope of this one, like you rise, I don't know, 1 and you run 2, rise 1 and run 2, like the slope would be the same, which would be this, the 2/5 for this line. If the slope is exactly the same and the y-intercept is different, this one's a negative, I don't know, negative like 1, 2. This one would be like a positive 1. If you have the same slope and a different y-intercept, they're never going to cross, which means they don't have any solutions. So this is one solution with crossing with the red line. If there's two lines that lie exactly on top of each other, then every solution works. They have all the same solutions. That means they're actually the same line. They're just lying on top of each other. And then when they have the same slope, there is no solution. The basic idea of checking that more than one point works with an equation goes for, I think, all the problems. So even if we don't get a picture, we maybe have like equations, we can still plug in points if they give us extra points. But we should see, I guess, for the next problems.
Cool. I think this lady, she never gave me the financial math. She just threw me to the algebra.
Does that mean like you skipped a part and you have to go back, or you?
Which is good because I think I only had to do one of these courses here, but
Okay.
I mean I might as well just finish.
Yeah. All right. Which is the best approximate solution to the system of linear equations? Y equals 1.5x minus 1. So that's the blue line. And then y equals 1 is the red line. So the solution is where they cross that red dot. So you have to just guess at what the x value is. We already know that the y value, it lands perfectly on the graph. That's what's the y value for the red line?
The 1.
It's the 1. So all we have to do is figure out, like, make
0,
a good guess.
It would be just 1, 0, or whatever.
Like it's slightly more than 1, right?
Yeah. The next one is like 1.
So which one
like
do you see?
1.33,
Yeah.
If it was a 1.83, it'd be way more.
Yeah, it would be farther than halfway, but it's less than halfway between 1 and 2. That was an easy one.
Yeah, that's a good one.
But that's when, like, for anything, if they ask you what's the answer or what's the solution to the system of equations, it's always going to be an x comma y. How many solutions does this linear system have? Okay, so this one's either one solution, no solutions, or infinite number of solutions.
And to figure this out, you would
So to figure this out, you could graph it, but there's one step that you'd have to do to make it easy to graph. Like the first one, the y equals 2x minus 5. Then minus 5 is the y-intercept, so you could go down. So you start from the middle and then go down 5, and then count. Like the slope would be 2 over 1. You could go up 2 over 1, up 2 over 1, and then just draw the line. But you don't actually have to graph it.
Okay.
You just need to make the second equation, like, solve for y, get the y by itself. And then we'll be able to see if they have the same slope but a different y-intercept. That means they're parallel, and that means they never cross, which means they don't have any solutions. If they turn out to be the exact same, like y equals 2x minus 5, it turns out that it's the same, then there's infinite number of solutions. And then the last one would be one solution, and you just plug in one of those to see what it is. So I think you should write down the second equation and then try to get the y by itself.
Then I would start with the 8, right?
Yeah, with the minus 8x, you would add 8x to both sides. So then it cancels out on the left side. And then I would write minus 4y.
20.
Oh, so
I'm doing it to...
Well, you're going to do it to both sides, but the negative 20 doesn't have an x on it. So you're just going to write the positive 8x either before the minus 20 or after the minus 20. And I would just write it before so that it looks the same as that top equation. I think you'll see it if you write it down afterwards. But what I would do is I would write plus 8x underneath the minus 8x on that left side. And then plus 8x on the side with the negative 20. And then you'll cancel out the 8x, or the negative 8x with the positive 8x on that left side. So then in the bottom, you'll write negative 4y equals, and then you can write 8x minus 20. And if you're trying to get the y by itself, what next do you do?
I'll do add the, well, that's going to be multiplication, right? Because it's negative 4 times y.
So then you have to do the opposite of that.
Divide that over.
Divide. Yeah. So divide each thing by negative 4. So I put the negative 4 underneath the negative 4y. I put the negative 4 underneath the 8x, and the negative 4 underneath the minus 20. And then, so now the y, when they cancel, the y would be by itself. And then it equals, and I think...
And then I can do the 20, right?
You can do the 20, but you can also do the negative, or the positive 8x, the 8x. You could divide that by negative 4. You just do the numbers. So like 8 divided by negative 4 would be negative 2. So then it would be negative 2x because you didn't do anything with the x.
And then I could do 20 negative divided by 4 negative. Equals 5.
And then so you'd say plus 5.
Okay. Oh yeah, because you still keep them there. So now it's y. So that was the top one.
Is it? It's y equals...
Well, no, because it's negative.
Negative 2x plus 5.
Plus.
And so it's slightly different. The slope is different, and the y-intercept is different. Like they're just opposite signs for each of those. So that means they're not parallel.
They're not on the same.
Yeah, and they're not lying right on top of each other. So it's going to be either the first answer or the second answer. So you can just plug in, if you want to try the first answer, the negative 2.5. Plug it in for the x, and then work on that right side, and then see if you get the 0 from the y coordinate.
So it'll be 2x times negative 2.5.
You're replacing, you're replacing the x with the negative 2. So
x,
2 times 2.5 negative equals, and then minus 5.
I got negative
10. That's not right, but it's still not the answer. So you did 2 times 2.5 negative?
Negative.
And then equals?
Yeah. Got negative 5.
Oh, I did it wrong. You're right. Yeah, minus 10. Or sorry, minus 5 equals minus 10.
Minus
yeah.
5, and I got 2.
Okay, so then the y value from the ordered pair, from the negative 2.5 comma 0, the y value is the 0. And we got negative 10. So that one's not right. Let's try the other one. 2.5.
Okay. 2 times 2.5.
Yeah.
Equals 5. 5 minus 5 equals 0.
All right, that's the one.
Okay, cool.
And then, like, if we didn't do all the other stuff, we would have to also try that in the second equation. It's gonna work, but we did all the work to know that it wasn't going to be an infinite number of solutions, and it wasn't going to be no solutions, because no solution would mean they have the same exact slope, but a different y-intercept. An infinite number of solutions mean they look exactly the same after you solve for y. So that has to be the answer.
On top of each other, right?
Yeah.
Which one gives you 2 solutions then?
None of them give you 2 solutions. It's either one solution, an infinite number of solutions, or 0 solutions. Because the idea is you have a solution where 2 straight lines touch each other. And the only way you can have straight lines touch each other is if they cross exactly once. Like they make like some kind of X. It's not gonna, if it curved around and crossed twice, it wouldn't be a straight line, it would be a curvy thing. So they wouldn't be 2 points where it crosses. It would only either be 1, or the lines lie right on top of each other, in which case all of the points on the line work. That means it's an infinite number of solutions. Or the 2 lines are parallel and they never cross. So then there's no points where they cross. That means no solution. but it can't be like 1 or 2 or 3, or it can't be 2 or 3 if we're talking about lines. If they can curve, then that's a different story, but that's different math.
Yeah, I haven't seen too many of them. I've seen a few of them, but I haven't really done those curvy ones.
It says she has written a system of 2 linear equations that has an infinite number of solutions. Okay, so infinite number of solutions means that the 2 lines lie right on top of each other. One of the equations of the system is that. Which could be the other equation? Okay, this is the same idea as the very first problem that we had, where you can plug in one of the points.
3, a -3, and then the regular, or the 3, right?
3, and then comma -1.
Point.
Yeah, so like 3 for the x and -1 for the y. That's for the far right point, the far right dot.
Oh, okay, I see.
And then if that works, then you also have to plug in the other one, which would be 0 for the x and -3 for the y. And I'm going to do that too.
And we're only plugging in, like if I were to do the second equation, I would just do 2/3 times 3, right?
Yeah. So you could
3.
you could do the 2 divided by 3 and then equals to make a decimal and then times it by 3.
Mm-hmm.
Yeah.
Okay, cool. So I did the second one. That one worked for the first one. Now I have to do.
Okay.
Would it be 0, -3?
Yep. I just checked the first point, so we're good there. Mm-hmm.
So the second one works for both.
Yep. So it's gonna be the one. Because if you had 2 points that work, that means all the points work because the line like is the same. It lies right on top of the other line, so it's all the points. I think you can get this one.
And the linear equation, the system of linear equation just means where they cross.
Yep.
Or this one, so it could be, all right, so that's a 0, 2, right?
Mm-hmm. Even though they don't give you actual equations, what they mean is like the 2 lines. They do have equations, and we could figure them out by doing the slope and the y-intercept, but it's just another way to write a linear function. So that's the easy one. That's a good one. Yeah. Cause the system to have an infinite number of solutions. So an infinite number of solutions, that means the line has to lie right on top of the other line, which essentially means they're the same line. So in that second equation, if you got the y all by itself, then we would be able to see the slope, which should be 6, and then we'll be able to see what the y-intercept is. So if you're getting the y all by itself for that second equation, do you know what you would work with first?
To get the y by itself?
Yeah.
I would do add the 3 right to itself, and then add it to the right 3.
Yeah, the 3x, because you're moving the
Yeah, the 3x.
yeah, yep. So it would cancel out on
And
the
then
left
write it down
side,
below.
and then you can write just a regular 3x minus 3 on the right side. And so we have 1/2
Well,
y
well,
equals 3x minus 3.
then I can turn that into decimal, or would I do it more of a? Because I'd have to multiply, right? Or
Yeah.
actually
So
divide it, right?
one way to think about it, the 1/2 times the y, that's the same thing as y divided by 2. Does that make sense to you, or you could do it with a decimal? Which way do you feel comfortable with?
Probably the decimal, just for decimal.
Okay, so then you could change it to a 0.5, so it's 0.5 times y. So then how do you get the y by itself?
So then I divide, right?
Uh-huh. And you have to do it to each of the things. It'll cancel on the left side, and you do it to both of the things on the right side.
Three divided by 0.5 equals 6.
Mm-hmm. So that'd be 6x
equals 6, and then 3 divided by -6.
So it should be y equals 6x minus 6.
Yeah.
So
Then now I just
the equation that you just got and that first equation, they're almost exactly the same, but they just want to know what b is. So minus b, what is b from what you got?
-6, right?
It would be that -6, but the minus is already there, so b is just regular 6.
Okay. So.
Because then it would be the exact same.
Like you did.
What's that?
If you were to read it just like you did, right? You just went up over, right?
Yeah, the rise would be 6. So
6.
rise, 6, and then over 1 would be 6 over 1, which is the same thing as the 6x. Like it's like 6x over 1. It's the same idea. Oh, I hope it says what's the approximate. Yep. See if you can figure out this one.
What did it say? Racial graphics.
So what is the best approximation for the solution of the system equations?
So one day.
It's a solution to a system of equations is always ordered pair, and that corresponds to the point where they cross.
So it'd be negative 2.2, I'd say, and -3.
Yep. The only other one would have been the negative, like 2.9. That's way too far. Some people would get confused and it's like, oh, it's right before the -2, so maybe it's negative 1.9, but that's backwards. Yeah, if you go left, it's negative 2.1, negative 2.2, negative 2.3 if you're going left. So yeah, that's it. Those ones are good ones.
Yeah, those are pretty good.
Okay. It's the same one where you make the bottom one, you get the y by itself. And then if they look exactly the same, that's infinite number of solutions. If they have the same slope but a different y-intercept, that means they have no solution. And then otherwise
So
you have to plug in.
I would do the bottom equation, the x.
Yeah.
Plus 2y. So that's just 1x, right? I can put.
Yep.
So I should divide, right?
So you're trying to get the
Or
y
not.
by itself, so you subtract the 1x. Because it's a positive 1x, so you subtract it,
Oh, okay.
and then it cancels out on the left side, and you subtract it, and so it would be negative 1x minus 8 on the right side.
So 2y equals negative 8 minus 4x. Alright, so now to get to 2, divide the 2,
Mm-hmm.
leave the y alone, divide the 2, and divide the 2. Negative 4. 0.5 like that. Negative.
Negative,
It's like
yes.
a 1. Yeah. X.
So y
So
equals what?
negative 4 and negative 4. I mean negative 0.5.
Okay, so the way, just to make it look the same as the first equation, you can change that minus 1/2 x. You can change that to a negative 0.5x, right?
Yeah.
That means the slope of that one is negative 0.5. And then on yours, I think you wrote negative 4 minus 0.5x, right?
Yeah.
You could write it as negative 0.5x minus 8. As long as they're still both negative, you can switch them around. So now they look almost the same. They have the same slope because the slope is just the number right in front of the x. So they have the same slope, which means they're slanted exactly the same amount, but the y-intercept for the top one is positive, the y-intercept for the bottom one is negative. So that means
they're not on top of each other.
They're not on top of each other, and since they have the same slope, they'll never touch each other.
So there's no solution.
It's no solution, because solutions to systems of linear equations, it's where they cross, and if they don't cross, then there's no solution. How many solutions does?
Same thing.
Yeah, same exact thing.
Okay. Add the 12x. Cancel that out. 12x minus 4.
Mm-hmm.
Two, so negative 6.
Mm-hmm. Negative 6 x, right?
Yeah, x, right.
Okay.
Then I got a regular 2.
So then it would be plus 2. Is that the same as the first one?
Yeah.
Yeah. So what do you think that means?
So that means it's they're on top of each other, right?
Yep. Cool. I feel like we got the hang of that one by the end.
Yeah. It's not like too bad.
Oh, with no solution. Okay, so before you scroll down, what does it mean when for a system of equations that has no solution?
So there'd have to be like another line, right? That's like here, it's going following.
Yeah, that's like the same steepness, right?
And it'll be almost the same, right? Just
moved over. It'll be like a copy of that moved over. So
yeah,
the slope, which is the -2 in front of the x, that's the slope, -2. So like you can even, it looks like in between, but 1, 2 over 1. So the slope is -2. For a line that would make it have no solution, it should still have a slope of -2, but a different y-intercept. So
the slope is -2.
the slope has to be -2.
It's got to be this one.
That one, how many can you select? Because what does it say to select?
2 of them, you're right. So
select 2 options. So slope.
Go to the even.
Oh yeah, that's the only 2. Yep. The y value, or the y-intercept, which is the b part, that has to be different. But both of those are different than the original one up there. So those all work. If the y values were exactly the same, then that would be the case where the 2 lines lie on top of each other.
See how we did.
Sweet. Let's see what another one. I got time if you got time.
Yeah, we can. It's kind of the same.
Okay. Substitution.
Not,
Solving systems of linear equations. Substitution. Yeah, let me show you on this one. Give me a second. I'm gonna pull up a problem. So a problem would be like solve, or like what's the solution? Solution to the system of linear equations. So 2x minus 9y equals 14, and x equals -6y plus 7. So the way that this one is set up makes it so that you can substitute. And here's the weird thing. Like, on the bottom, I have x all by itself. That's the hint. Whichever variable is by itself, you're going to use this part. So like in the bottom equation, x is by itself, so I'm going to use this equation. And I'm going to use it in the first equation. This is a weird thing, but just think of it like this. I'm going to say like x, another name for x, that's what the equal sign means. It means it's the exact same thing. Another name for x is -6y plus 7. I could either say x, which is the simple thing to say, or I could say -6y plus 7. They mean exactly the same thing. X is -6y plus 7. So, since I have another name for x, I can put it into the first equation. Instead of writing this x, I can write its other name. negative 6y plus 7. And then I'll be able to figure out a y value. There's a lot of steps to this. If there's any graphs, we can just do it the way that we did. But if there aren't any graphs, we'd either have to graph it or we could do it like this. So if there's a variable solved for already, then you take whatever that variable equals, and then you just substitute it in for that same variable in the other equation. So I'm going to write down 2, that's just this 2. And then instead of writing x, I'm going to substitute. I'll actually put this in parentheses, because instead of writing x, I'm going to write negative 6y plus 7. And then minus 9y equals 14. Now this, you've solved some stuff like this before. Does this make sense so far? Or do you have a question or anything?
Yeah, I'm good. Okay. Can you just figure out, you're going to do it anyways, right?
Yeah, I'm going to do the rest of it. Anyways. So the first step was to substitute, because x is this, and so you substitute it in for that x. And then since it's 2 times x, that's 2 times the parentheses.
Oh, you are going to distribute.
Yeah, negative 6y plus 7. I'm going to distribute, so I get 2 times negative 6 would be negative 12, and then the y is still there. 2 times 7 is 14. So I'm going to do plus 14 because it's a positive. And then I can do minus 9y equals 14. On the same side of the equal sign, I have the negative 12y and the negative 9y. So I can combine those. So negative 12. I mean, they're already on the same side of the equal sign, so I don't do the opposite. Yeah. So I just do negative 12.
Yeah, you're just going to combine it.
And then negative 9, yeah. So that would be 21, negative 21y, and then the plus 14 equals 14. And I'm going to try and get the y by itself, so I can subtract 14. From both sides. That cancels. This also cancels, so I'm going to write 0, because 14 minus 14 is 0. And then I have negative 21y. And then the last thing I do is divide by negative 21. So that cancels. And I get y equals, well, 0 divided by any number is still just 0. And so the solution, what's the solution to the system of equations, or of linear equations? The solution is always something, comma, something. We know this, but we don't know what the x value is supposed to be. So the way we get it, just remember, there's a lot of stuff here, but the way we get it is we have a definition. X is negative 6y plus 7, and we know what y is. So I'm going to rewrite that. X is negative 6y plus 7, except for, instead of that y, I'm going to plug in what I found, 0. So then x equals negative 6 times 0 plus 7. So x equals, that's 0 plus 7. So x just equals 7. So that is my answer. That's solving by substitution. I feel like there might be some easier problems. This was a pretty big one. But the basic thing is look for one equation where the variable is already by itself. I'm trying to get rid of all this. So look for the equation where the variable is already by itself. In this case, the x was already by itself. So whatever is on the other side, you put into the other equation for x. Sometimes, like maybe it would be 3x plus 4y equals 6 and y equals 2x minus 1. In this case, y is by itself, so I would take all of this. I would take all of this and replace the y there with 2x minus 1. So then I would write 3x plus 4, parentheses, 2x minus 1, and then equals 6, and then I do all the rest of those steps. But that's the main idea. It might be easier than that. It might not. But that was
All right.
This was just a separate example. So this is the answer. All right, let's see what we got. Tables represent two linear functions in a system. What is the solution to the system? Weird. None of them are exactly the same. The x's are the same, but all the y values are different, right?
Yeah. Only 1, 2. There's a 2 in there for both, but then.
Yeah, it's not in the right spot. So one way is to graph them and then see where they cross, but that's not even by substitution. I don't know. 0, 10. Yeah, I'm gonna graph it real quick. It would be easier if you had graph paper too, but I can do that kind of quick.
So you're gonna graph it, right? You want to see where both of them are two different.
They're two different lines, but they should cross at some point.
Okay, and that's what we're gonna.
Yeah, and I'm gonna graph the easiest 2 points because the only thing I need to draw a line is just 2 points. Like I don't need 3 because the third point would just be an extra one that's on the same line. So I'm just gonna do 0, 10. And 0, 1, 2, 10. 0, 10, and 2, 2. 1, 2, 1, 2. So now I can draw a line between those points. And then on the other one, I'll do 0, 2, 0, 1, 2, and 2, negative 4, 1, 2, 1, 2, 3, 4. Oh, it's way down there. Oh, I don't know how they're... Oh! This is not by substitution. Okay, let me do this and then I'll explain it. And we'll pause it and explain it. The slope would be... 0, 10 equals x plus 10, and then the slope would be 6. And then oh, it's the last one. Shoot, I could have figured that one out. You click on the last one and then save and exit. Oh, wait. Not yet. Cancel. Let me get a picture. Okay, you're good. So there's two ways that you can think about this. The first one is by graphing it, and the other one is by getting the slope and the y-intercept. I'm going to show you the graphing one first, because I think that's a little bit easier to see. So if how can I do this? Whoops. Okay, just so I can see the points. So if I look at this, the simplest points to graph would be the 0, 10 and the 2, 2. Do you see where I got those?
Yep.
So all I'm doing is saying at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's one of them. And then the other one is 2, 2. So that's right there. And then draw the line right through it. And that goes down that way. And then up that way. If I did -2, 18, that would be -2 and then all the way up 18. Like somewhere way up here. That would just be an extra point. I wouldn't need that actually to graph this. So I'm going to only use 2 because the next ones would just fall on the line anyway. So that's one. And then I'm going to do the same idea for this. 0, 2 and 2, -4. So 0, 2 and 2, -4. 1, 2, 3, 4. So this one, if I zoom out, let's make this a little bit better. Oh, I hope I didn't do this one wrong. No. So if I drew this line, and then I drew this line, eventually they're going to cross somewhere down here if I continue them on. Right?
Yeah.
So that's how I knew it had to be this point. Because 8, -22 is over 8, which is in the correct direction, and then down 22, that's going to be way down there. If I looked at 8, 26, that would have been 8 over and then up 26. That would have been somewhere over here, and they don't even go over there. Same with 1, 6. 1, 1, 2, 3, 4, 5, 6. They're not crossing here because this one's going like that. And then 1, 0. 1, 0. They're not crossing there either because they're still going. So it just had to be that one if you graphed it. The other way, I think, is more complicated, and I'll save that until we have to actually go through that. But I wrote down the equations for each of them, and then I saw wait, you can just do it by graphing. So that was a weird one. That was our first one?
Yep.
That sucks. All right, we'll see on the next one.
Make it easier.
Was he gonna kick us out? Hello?
No?
Hello? Hey.
Thanks for waiting.
Yeah, no problem.
Yeah, I don't know what the hell my Wi-Fi went off on the laptop and I couldn't connect back to it to restart this.
We were paused though, right?
Yeah, I'm pretty
Or
sure.
It probably paused it anyway, if it did.
Yeah, it'll still show you the last one.
Yeah.
We didn't even get into it. Just went straight.
Okay. So, well, I forgot that. Well, those are big numbers, but you can plug it into both. It has to work in both. So, like, you can do the -40 for the x and 19 for the y, and do it for both of them. Or you could go through all this. That might be easiest, actually.
And that's like, I do the second equation, not the first writer. I could do the top one, the first one.
Yeah.
It's easier.
But well, I mean, you have to do it into both equations eventually. So like, if it doesn't work in the top one, okay, then skip to answer B and then try it. Yeah, but it's easier in the top one first.
Okay.
And if it does work, then you have to check that ordered pair in the second equation. If it doesn't work, you can just move on.
Oh, got it.
So what'd you get for the first one?
Got 118.
Me too, and it should be 19. So that one,
19,
yeah, that one's not right. So we can just move on.
Cool. So I got 55 for that one.
Yeah, so that one works. Now we have to try that same one in the second equation.
And we just put it for a y, right?
So you put it in both. So the x,
okay.
you replace it with -19. So 5 times -19, and then write that down. And then the 2 times the 55, and then write that down and add those together, and then see if you get 15.
Yeah, that works.
Yeah, me too. If it didn't, then we just have to keep going for the other ones. But okay. It worked in both, so we're good.
Same thing.
Well, that second equation is different, but yeah, it's the same thing, except for now you only have to check in the first equation because there is no x in the second one.
Well, okay.
So here's the thing. You're supposed to plug in an x and a y into the top one and see if it works out. The y value, like if you chose the first answer, the x value would be -21, and you do stuff with that, and then you see if it ends up equaling 9, because that's what it's supposed to equal to. On the second equation, the y value is 9. There is no x. And it doesn't matter. Like the y value is just equal 9. There is no x. That means there is no slope either. So that means this is just a horizontal line that crosses the y-axis at 9. The answers cannot be the last answer or the second answer. So it's either 1 or 3 because those are the only ones that have a y value of 9. And this one, the second equation, has to have a y value of 9. So it's either going to be the first one or the third one.
The third one.
Yeah, but you still try it in the first
equation. It's not the first one.
Not the, oh, it's not the first one?
No.
Okay. So then it has to be the third one, but we can double check it.
Six equals, yeah, it's the second one.
Yeah.
I mean the third one.
Not bad. Okay. Ernesto tried to determine the solution of the system of equations using substitution. His work is shown below. Step 1. X equals y plus 7. So step 1, he took the top equation and he added the y. He moved the y over to the right side, so he added it. Do you see that?
Yeah.
So he took that y.
He took the x out, right?
Yeah, and he got the x by itself. So he just moved the y over, so that's be positive y, and then it's a positive 7, so he put plus 7. So that's correct. And then he took the y plus the 7, because that's what x is. That's the, like, you can call it x or you can call it y plus 7. So in the other equation, instead of writing x, he put the y plus 7. So it's 3, and then
like
parentheses.
Right?
Yeah, he substituted. So 3 parentheses y plus 7. That looks good. And then wrote down the minus 2y equals 8. Okay. What is he supposed to do after that?
Supposed to distribute the 3 over to the y and 7.
But he didn't do it to the 7. Do you see that?
He just did it to the 1. Yeah.
So it should be
That's just
step 3. Yeah. Not too bad.
Yeah, that's fine.
Okay.
We're just going to plug in these numbers and
see which one comes out to be the same for both. Yeah, you just plug it into both, I think. And just see what comes out for y. So like, plug in the 6, wait, how many bars would the team need to purchase from each company? So you plug in the 6 to both and see if you get the same number. And if not, you plug in the 8 to both and see if you get the same number. And then so forth.
not 6.
Nope.
It's not 8 either.
Not 8 either.
last one, I think.
Yeah, it's not the 30. But you got to do the
Yeah.
0.5 times the 40 first and then add the 10.
Then plus 10. Right?
Yeah.
So 5 times 40, 30. 0.5. Yeah, that's the last one.
Yeah. Wait. Actually, let's just make sure. Because the Y value equals 30. How many bars would the team need to purchase? They need to buy 40 bars, and the cost would be 30. Y is the total cost. Okay, yeah, that's good. That was a trick question, but it's good.
Did a double check, yeah, you're right.
Kathleen Arnob? Arnob? That's a
What good name is that, man?
Sounds like he gets beat up a lot.
Probably said his name is Arnold or something.
Yeah. I think you have to scroll down a little bit. I think distance is the y-axis and x is the time. Okay. Do you have a guess for this one?
Many minutes since it take on the catcher. So this is where they meet.
Mm-hmm.
And it's asking how much time, right?
Yep. So it's asking for the x.
Or 73 point.
That's really close. I
think it's 73.5 because the middle would be here, right? And then it's here. I don't know. What do you think?
I think you're right.
Close.
But the way we can test it is we plug in the 73.5 to the equations, and they both have to come out with the same number, which would be 10. Okay. So is that 2 divided by 15?
Yes, it'd be 7.5. Right?
Wait, 2 divided by 15 equals, and then times 73.5. Oh, that equals 9.8. Well, does the other one equal 9.8? Let's see. 1 divided by 15 equals times 73.5 equals plus 5 equals.
4.9. So yeah, it does. Right.
Well, I got 9.9.
9.9. Yeah.
So one was 9.8, one was 9.9. Let's try the 75 then. I think it's still 73.5, but let me just check real quick. So 2 divided by 15 equals times 75 equals. That equals 10. 2 divided by 15 times 75 is 10. And then 1 divided by 15 equals times 75 equals plus 5 equals. Oh, it is 75. Because they both equal 10 on that. It's weird. It looks like a little bit less, but
it looks a little off, yeah, but I guess.
I think, we'll see at the end, but I think 75.
Yeah, they're both equal.
What is the solution to the system of equations?
This would be like that one, right? So I can just add the first one, see it.
Yeah, plug in the first one and see if it works. So you plug in the negative 1.6 for the x, times it by 1.5 equals, and then minus 4, and then see if that equals 1.6. And then we'll try it on the other one if it works.
The first one's wrong.
I got the same. That it is wrong. Yeah, I agree. That's what I'm saying.
Oh, okay. Yeah.
Mm,
So the last one's the only one I actually got the matching number.
all right, minus 4
4.
equals, yeah. Yep. And then if you look at the second equation, the x is the 1.6. If you plugged it in, you just get negative 1.6, right?
Yeah.
And then that's what y equals negative 1.6. Maybe that would have been the easier way to start, but it still has to work in both of them, so that's good. Same thing, I'd probably just change it to decimals. Oh, actually, x equals negative 2. That's a hint, except for all the answers have x equals negative 2, so it's not too much. So that means just plug in negative 2 to the top equation and see what you get out, and then test those y values. Does that make sense?
Yeah. Yeah.
Okay.
So for the first one, I got 1.66666.
And it's positive, so that means the first answer is not right because that's a negative. Let's see.
The second one I got 3 so far.
5 divided by 3. Yep. I mean, you're plugging in negative 2 every single time, so it's not like you just have to see if the answer is 1.6666 repeating. Oh boy.
This is one of those ones.
Yeah, I think graphing. The table represents two linear functions in a system. What is the solution to this system?
So when you do this graphing, you do the same one, like the same 2, right? So if you did the bottom 2, you're gonna do the bottom 2 for the right.
You don't have to. I just did whichever ones were easiest, and they were just the smallest numbers. So,
all right.
And same with this one. I do the 0 and the 2, and then 0, 2, and then 3, 14, and then draw the line between those, and then do the 0, negative 12, and the 3, negative 3, and then we'll see which one it's closest to. And if you could trace like a straight edge to make the line perfect, it might be easier to see too.
And this, we just want to know where they're going to cross, right?
Yeah. They make it so hard to graph. Um, I think it's. Whoa. I think it might be the first one. Yeah. Oh, no. I did that totally wrong. Definitely not the first one.
They are going to cross down below.
You said they are going to cross down below, or they're not?
Oh, negative, yeah.
Yeah, they have to.
Yeah, they're all negatives.
Shoot. That's not an easy one to see from the graph. I say let's guess on this one, because this is...
I'm going to guess with A. Unless you think it's...
I would say that's 4.
Or further down.
Yeah, further down. Either the last two. One of those. I don't know which one. They're so close together, it's hard to do from graphing. That's not even one by substitution. That's a weird one.
Yeah, that's just throwing random crap in there.
We'll see. What is the solution to the system? I think you know how to do this one.
I'll go off the top one, right? Just because.
At first, yeah. And then if it works out, so like you can plug in the -8 instead of the x. So 1 divided by 3, that's 0.33333 times the -8 equals, and then minus the 10, and see if you get the 6.
6. Second one's wrong, and the first one. The third one, I got it, but I'm gonna check the last one just in case if that one doesn't work.
Okay. Yeah, I got the first two wrong.
Yeah, so the third one's the only one that actually works. All the other ones give you.
Yep.
Something wrong.
Cool. All right, let's see about that other one. Hey!
Nice.
I think this one's by elimination. That's what it's going to say. Same exact thing except for eliminate. Oh, no, never mind.
Solving systems, introducing
linear combinations. Oh, this is by elimination. Hey, so
let me know if you got time tomorrow.
Yeah, I think I will.
All right.
This one, yeah, I think it'll be the exact same thing actually. So,
okay.
Yeah, I'll talk to you tomorrow then. Yeah.
All right, yes, sir. Favor.
All right, night.
Have a good night.